Hi, welcome. In today's tutorial, I'm going to take you through how to perform paired samples t-test using SPSS. So without wasting much time, let's start. Now, the paired sample t-test is used when a particular observation is measured twice to see whether there has been a change or some level of effectiveness. For you to understand this better, I've decided to use Herbalife nutrition as an example. Now, there's this particular combo those who sell Herbalife usually sell out for those who want to gain weight. Now, I want to check statistically if the Herbalife nutrition for gaining weight is effective or not. So I decided to collect samples of 11 students who took the Herbalife product for gaining weight. If you look at the second column, which is WB, that is weight before the Herbalife product. And then the third column is weight after Herbalife product. Okay. And then the first column is the name of each respondent. When we look at the first respondent's name is Fafali. And then her weight before taking the Herbalife nutrition was 65 kg. And then her weight after taking the Herbalife nutrition is 71 kg. The second respondent, her weight before the Herbalife nutrition was 81. And her weight after the Herbalife is 85. The third respondent too, her weight before was 71 and her weight after is 67, going in that manner. The purpose of taking the Herbalife is to gain weight, isn't it? But when we look at the first respondent, her weight has actually increased after taking the Herbalife. The second respondent weight has also increased. But when you look at the third respondent, her weight has rather decreased. The fourth respondent weight has increased, going in that manner. But when you look from the beginning to the end, you realize that those whose weight has actually increased are more than those whose weight decreased. But this is not enough for us to say that the Herbalife nutrition product is effective. So we are interested in testing whether this Herbalife product is statistically significantly effective. So to do that, first we click on Analyze. Then we go to Compare Means. Then you move to the right and then come down to Paired Samples t-test. Then you click on it. Then the Paired Samples t-test dialog box displays. So first you select the weight before Herbalife in kg. Then you click on the arrow here to move it to variable 1. Then after that you click on weight after Herbalife in kg. Then you click on the arrow to move it to variable 2 here. You click on option to check if the confidence interval percentage is actually what you want to use. The default one is 95% and we are using 95% confidence. And that means 5% level of significance. Okay, that is 100 minus 95. If you are using 99% confidence, that is 1% level of significance. So since we are using 95, we just click on continue. Then after that, then we click on OK. Then instantly SPSS will bring out the output. Now in the output we will have 3 tables. The first table is the paired samples statistics. And then the second table is the paired samples correlations. And then the third one is the paired samples test. But in this particular video, I'm going to focus on the first table and then the third table. When you look at the first table, which is the paired samples statistic. Now for the weight before Herbalife in kg, the mean is 70.7273. And then the sample size is 11. And this is the standard deviation and this is the standard error. And then when we take the weight after Herbalife in kg, the mean is 75.6364. And the sample size is also 11. And then this is the standard deviation and this is the standard error of the mean as well. Now when we look at the mean of the weight after Herbalife, we can see clearly that it is more than the mean weight before Herbalife. Now, the fact that the mean weight after Herbalife is more than the mean weight before Herbalife is not enough for us to conclude that the Herbalife product for gaining weight is effective. So we are interested in the hypothesis test part of it. Okay, so let's come to the paired samples test. Now first, let's state the null and the alternate hypothesis. The null hypothesis states that the mean weight after Herbalife is not statistically significantly different from the mean weight before Herbalife. What that means is that the mean weight before Herbalife and after Herbalife are not different from each other. That's what it means. And if you are saying they are not different, it means you are trying to say that the Herbalife nutrition product is not effective in helping people to gain weight. That's what you are trying to say. And then the alternate hypothesis states that the mean weight after Herbalife is statistically significantly different from the mean weight before Herbalife. So for this one, you are saying that there's a difference in their mean. Okay. And what that also means is that you are trying to say the Herbalife product is effective in helping people gain weight. Now, at the end of the day, our decision will be to either reject or not to reject the null hypothesis. And if we reject the null hypothesis, it means that we are supporting the alternate hypothesis. But if we do not reject the null hypothesis, it means we are going for the null hypothesis. So to do that, let's come to the paired samples t-test. Now when we look at the area of the paired differences, this mean here is the mean difference. Okay. Now when you look at the mean difference is negative 4.90909. Now the reason the mean difference is negative is that the mean weight before Herbalife in kg is less than the mean weight after Herbalife in kg. This mean difference of 4.90909 means that the mean weight of those who take the Herbalife to gain weight, that is after taking it, is 4.90909 more than their mean weight before taking the Herbalife. Now to decide whether to reject the null hypothesis or not, I'm going to show you three methods of doing that. Now the first method is the p-value method. For the p-value method, first write this rule down. The rule is that if the p-value is less than or equal to the level of significance, then the decision is to reject the null hypothesis. But if the p-value is greater than the level of significance, do not reject the null hypothesis. Now let's look at this. Remember, the level of confidence we gave was 95%. And if you have a level of confidence of 95%, it means that your level of significance is 5%. That is 100 minus 95. So we know our level of significance to be 5%. Let's convert it to decimals. 5% means 5 divided by 100, and that is 0.05. So let's look at our p-value. Now from this table, our p-value is the one they've written SIG two-tailed on, which is 0.001. So this is the p-value. So now let's compare this p-value and the level of significance. Remember, the level of significance is 0.05. So let's compare this and the level of significance. When we compare, we can see that the p-value of 0.001 is less than the level of significance of 0.05. So since the p-value of 0.001 is less than the level of significance of 0.05, then we are going to reject the null hypothesis. And remember, it is the null hypothesis that says that the Herbalife is not effective. Since we are rejecting the null hypothesis which says the Herbalife is not significantly effective, it means we are supporting the alternate hypothesis which says that the Herbalife product is effective. So we can conclude that the Herbalife product is effective in making people gain weight. Okay. Now let's look at the second method. The second method is using the critical value method. Okay. Now to use the critical value method, the rule is that if the test statistic, the one we have here is the test statistic. Okay. If the test statistic is greater than the critical value, we reject the null hypothesis. But if the test statistic is less than the critical value of t, we do not reject the null hypothesis. So let's check. Now to check that, first we need to go and look for the critical value of t. Now to look for the critical value of t, we need two things. We need the level of significance and then we need the degrees of freedom. Now we know the level of significance to be 5% or 0.05. But when you look at the table, we have the degree of freedom to be 10. Okay. So now we know the degree of freedom and we know the level of significance. So let's go to the t table to check the critical value. So when we come to the t table, remember the level of significance is 5%. So we check for it at where they've written two-tailed test. So when we look at where they've written two-tailed test, this is the 5% at the front of it. Okay. And our degrees of freedom was 10. So we trace the 5% down to where we have 10. So when we trace it down there, we have 2.228. Okay, so the critical value of T is 2.228. So let's go back to SPSS and then make our decision. Since our critical value is 2.228, let's compare it with the test statistic. Now, to compare it with the test statistic, please take the absolute value of the test statistic. Ignore the negative. The absolute value of the test statistic is 4.803. Now, let's compare the absolute value of the test statistic to the absolute value of the critical value. Now, when you look at it, you see that the test statistic of 4.803 is greater than the critical value of 2.228. So since the test statistic of 4.803 is greater than the critical value of 2.228, then the decision is to reject the null hypothesis. So have you seen that we've ended making the same decision we made using the p-value method? So we've rejected the null hypothesis, which says that the Herbalife product is not effective. So it means that we are supporting the alternate hypothesis, which says it is effective. Okay. Then let's look at the third method of making decision. Now, the third method is using the 95% confidence interval of the difference. Now, to use it, you check the upper and the lower. If the upper and the lower have the same sign, you are going to reject the null hypothesis. When I say the same sign, it means if they are both negative or if they are both positive, okay, we reject the null hypothesis. But if they have different signs, that is, if one is negative and the other is positive, then we do not reject the null hypothesis. So when we look at the lower and the upper here, you see that they have the same sign. They are both negative. So since they are both having the same sign, the decision is to reject the null hypothesis. And remember, it is the null hypothesis which says that the Herbalife is not effective. So we are rejecting it. So it means we are supporting the alternative that says that the Herbalife weight gaining combo is effective. So finally, we are going to conclude that the Herbalife product weight gain combo is effective in making people gain weight. So you can check the description below or check our channel playlist for videos on SPSS, STATA, Excel, MVivo and other softwares. Okay. So subscribe to the channel so that you can have easy access to our videos whenever we post them. Thank you.